Okay, we are given two curves, and we're asked to find the coordinates of each intersection point. So it could be more than one. And since we have some squares floating around in both equations actually, so the right hand side's a quadratic, the left hand side's actually a hyperbola, so we would expect more than one solution, usually. Before you even start this question, try graph it. Even though this is an algebra paper, using your graphics calculator can definitely point you in the right direction. If you know how many solutions and what they are, then solving algebraically you can confirm that. Alright, so to solve this, we'll simultaneously solve it or substitute one of the equations into the other. Depending on how you do it, it might be easier to do it one way or the other. But before we get there, actually I will just expand and simplify this quadratic. X squared plus x minus 1 minus 2. So the plus x and the minus x will cancel, and then we're left with minus 1 minus 2 to give us minus 3. So that's just expanding and simplifying that quadratic equation. Now, you might be thinking, alright, let's plug in y in here, so we replace the y in that first equation with x squared minus 3, but then we'll have a quartic, right? Because we get x squared equals y, which is x squared minus 3, all to the power of 2, which is possible to solve, but it's a little bit harder. So if you get there and you're like, uh-oh, what do I do? Try substitute it a different way. So instead, with this quadratic, I will rearrange for x squared as y plus 3. So I just added 3 to both sides. And now we can substitute in x squared into the hyperbola equation. So replacing this x squared up here with y plus 3, substituting, y plus 3 equals y squared plus 1. And that's a quadratic equation, which is much nicer to solve. So let's solve for that. Bring everything to one side. I'll take it to the right hand side. So that's y squared minus y, and then 1 minus 3 minus 2 equals 0. Great. Now we can solve for y by factorizing or using the quadratic formula. So multiplies to negative 2, adds to negative 1, negative 2 and positive 1. And then solving for y would equal positive 2, or y would equal negative 1. Great, so those are some y values. But we're looking for coordinates. So to get the x values, we could use either function. I'm just going to use this quadratic up here. Just split this up. So if y equals x squared, actually, let's just rearrange this for x first. It'll make our lives a bit easier. So x squared equals y plus 3. So x equals plus or minus the square root of y plus 3. Alright, so I just rearranged that quadratic. So now we can substitute in our y value to get the corresponding x values. So I'll just pause here. How many solutions do you think there are? So we have two y values. How many x values will we expect? Alright, so let's give it a go. So when y equals 2, x will equal plus or minus. So remember, the plus or minus comes from square rooting. We could have two solutions. The square root of y, which is 2, plus 3. So x could be plus or minus root 5. So the points generated at y equals 2 would actually be root 5 and 2 and negative root 5 and 2. Alright, same y value, but positive or negative x value. Similarly with when y equals negative 1, x would equal plus or minus square root of y, negative 1, plus 3, which is a square root, plus or minus the square root of 2. So the points would be at positive root 2, negative 1, and negative root 2, negative 1. So we have 1, 2, 3, 4 points of intersection. And definitely confirm this with your calculator by graphing both sides and using GSolve to find the intersection points.